We all know that the computer is a very practical thing out there in the physical world. It will pay for a lot of your salaries, right? But the computer was invented in order to help clarify a question posed by David Hilbert about the foundations of mathematics. David Hilbert asked, "Is there a mechanical procedure to decide whether any mathematical statement is true or false?" Alan Turing's remarkable 1936 paper on computable numbers with an application to the Entscheidungsproblem not only settled that matter, it marked a turning point in modern mathematics. On the one hand, the computer entered center stage as a major mathematical concept. On the other hand, Turing established a link between mathematics and physics by talking about what a machine can accomplish. It is amazing how far these ideas have come in a comparatively short amount of time. A small stream has turned into a major river. The mathematical model of the computer that Turing proposed, commonly referred to as the Turing machine, is a black box with a finite number of internal states. The box can read and write on an infinite paper tape which is divided into squares. A digit or letter may be written on each square of the tape, or the square may be blank. Each second, the machine performs one or more of the following actions. It may stop. It may shift the tape one square to the right or one square to the left. It may erase the square on which the read-write head is positioned, or it may read or write a symbol on the square on which the read-write head is positioned. Turing came up with the idea of a computer as a mathematical concept. It's a perfect computer, one that never makes mistakes, one that has as much time and space as it needs to work. It is always finite, but the calculation can go on as long as it has to. The assumption of infinite time and infinite memory was necessary because Turing was trying to disprove the decision problem posed by David Hilbert. But once someone realized the practicality of this invention, the next logical step was to study the time needed to do the calculations, that is to say, their time complexity. If we consider the physics of the universe, then the situation is always finite, because we have always a finitely resourced universe, and there is a theoretical maximum on the information capacity of the entire universe. But a universal Turing machine is always more powerful than any physical one, be it on Dune or on Earth. The notion of computational complexity is a mix of mathematics and physics because on the one hand, it would be true in any universe, given any set of physical laws, and on the other hand, it considers the resource boundedness of computation.